Hi students, welcome back to Learning Management System, Department of Collegiate and Technical Education. In today's session, we will discuss the fifth unit, Decrease and Conquer of session 1 of the subject, Design and Analysis of Algorithms. The course outcome of this unit is to describe various problems using decrease and conquer. And in this first session, we will discuss the introduction and variations of decrease and conquer technique. So, what is decrease and conquer? As you studied divide and conquer in the previous unit, this decrease and conquer is also similar to divide and conquer, except instead of partitioning a problem into multiple subproblems of smaller size, we use some technique to reduce our problem into a single problem that is smaller than the original one. For example, in divide and conquer, what we have done in merge sort, we divided the given array into sub arrays and we sorted the sub arrays and later we combined them. Where in divide and conquer technique, there all the subproblems solution should be solved. All problems subproblems ಏನಿದೆ solution find out ಮಾಡಬೇಕಾಗುತ್ತೆ. But the major difference between decrease and conquer and divide and conquer is decrease and conquer ಅಲ್ಲಿ ನಾವು entire problem ಅನ್ನು solve ಮಾಡೋದು is not compulsion. We reduce the given problem into a smaller instance of that problem and we try to find out the solution of that smaller problem and we arrive to the solution to the original problem. For more understanding purpose, let me take one example which is a binary search. Binary search ಅಲ್ಲಿ ಏನು ಮಾಡ್ತೀವಿ ನಾವು, for the given array we try to find whether a given key is present in the array or not. Linear search and binary search ಗೆ difference ಏನಂತಂದ್ರೆ, linear search ಅಲ್ಲಿ we try to compare the given key with array elements until the key is matched. Okay, but in binary search we divide the given array and we find the mid value and we compare that key with the mid value. If the key is less than the mid value, then we try to find out the left side of the mid by skipping the right side subarray. If the key is greater than the mid value, then we skip the left part of the subarray and we try to find the matching in the right side. So ಏನಾಗ್ತಿದೆ ಇಲ್ಲಿ, we not solving the entire problem, we reduced the problem into its smaller instance and we try to find the solution to the smaller problem and we'll get the solution to the original problem. This is the major difference between divide and conquer and decrease and conquer. So let me take one example for binary search. So this is the given array of elements 20, 30, 40, 50, 60, 70, 80, 90 and 100. The size of the array is 9, indexed from 0 to 8. And what is the search key? Search key is 30. So linear search alladre ನಾವು ಏನು ಮಾಡ್ತೀವಿ, 30 ಅನ್ನು starting of the index element ಇಂದ ಮ್ಯಾಚ್ ಮಾಡ್ಕೊಂತ ಹೋಗ್ತೀವಿ, a of 0, a of 1 up to a of n-1 ವರೆಗೆ. But in binary search what we do, we find the mid position. So what is the formula for mid position? Finding the mid, low plus high divided by 2. Low andre a of 0, high andre n-1. Hence after finding the mid value, you will get the mid position as 4, whose value is 60. and here we compare the search key, which is 30, to the 60. After comparison, search key is the less than the mid value. Hence, searching should take place left sub array part by skipping the right sub array. Now right sub array ಅಲ್ಲಿ search ಮಾಡೋದಿಲ್ಲ, and the problem size is reduced almost half of the problem. So ಈಗ ನಮಗೆ ಇರೋಂಥ ಪ್ರಾಬ್ಲಮ್ ಏನು, ಸರ್ಚ್ ಮಾಡಬೇಕಾಗಿರೋದಲ್ಲಿ ಲೆಫ್ಟ್ ಸೈಡ್ ಅರೇದಲ್ಲಿ whose size is 0 to 3, almost half. Okay students, hence the searching takes place towards left side of the mid position by skipping the right side sub array. This is how decrease and conquer works. Now let us discuss the variations of decrease and conquer. There are three major variations of decrease and conquer, that is decrease by a constant, decrease by a constant factor, and last one, variable size decrease. Let us discuss these three variations one by one. In a decrease by constant variation, the size of an instance is reduced by the same constant on each iteration of the algorithm. So ಪ್ರತಿಯೊಂದು iteration of the algorithm ದಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಪ್ರಾಬ್ಲಮ್ ಸೈಜ್ ಅನ್ನು ಸೇಮ್ ಕಾನ್ಸ್ಟಂಟ್ ಇಂದ ರೆಡ್ಯೂಸ್ಡ್ ಆಗುತ್ತೆ. Here it is a pictorial representation of this variation. The problem of size n is reduced by the constant value 1, that is -1, subproblem of size n minus 1, and we try to find out the solution to this subproblem, and later we arrive the solution to the original problem. For better understanding, let me take the example of computing the a to the power n exponential problem, where a is not equal to 0 and n is a non-negative integer. Hence, the relationship between this a and the size n is obtained by a to the power of n is equal to a to the power of n minus 1 into a. Okay students, for example, if I want to compute the 5 to the power of 3, then I can compute this in this way, 5 to the power of 2 into 5. Hence, I reduced the power factor, that is 3, by -1, balancing the equation. 5 to the power of 3 equal to 5 square into 5. Hence, by establishing the relationship of this function, we can define this as a recursive function or definition, f of n equal to f of n minus 1 into a when n is greater than 0. Otherwise, it will be 1 if n equal to 0. Coming to the second variation, decrease by a constant factor. So here in the second variation, this technique suggests reducing a problem instance by the same constant factor on each iteration of the algorithm. So ಇಲ್ಲಿ ಏನು ಮಾಡ್ತೀವಿ, ಎವ್ರಿ ಇಟರೇಷನ್ ಆಫ್ ಅಲ್ಗೋರಿದಮ್ ಅಲ್ಲಿ ಪ್ರಾಬ್ಲಮ್ ಸೈಜ್ ಅನ್ನು ಕಾನ್ಸ್ಟಂಟ್ ಫ್ಯಾಕ್ಟರ್ ಇಂದ ನಾವು ರೆಡ್ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, ಡಿವೈಡ್ ಬೈ 2, ಫಾರ್ ಎವ್ರಿ ಇಟರೇಷನ್ಗೆ ಡಿವೈಡ್ ಬೈ 2 ಮಾಡೋದನ್ನ ಒಂದು ಕಾನ್ಸ್ಟಂಟ್ ಫ್ಯಾಕ್ಟರ್ ಎಕ್ಸಾಂಪಲ್ ಆಗುತ್ತೆ. ವೆರಾಸ್ ಡಿಕ್ರೀಸ್ ಬೈ ಕಾನ್ಸ್ಟಂಟ್ ಅಲ್ಲಿ ಏನು ಮಾಡಿದ್ವಿ, we reduce the problem size by same constant. Here it is a pictorial representation of the decrease by a constant factor variation. The problem of size n is reduced by the constant factor 2 every time the problem size n is divided by 2, and we find the solution to the sub problem, and later we arrive to the solution to the original problem. So let me revisit the binary search. So ಏನು ಮಾಡಿದ್ವಿ ನಾವು binary search ಅಲ್ಲಿ, binary search entire size ಏನಿರುತ್ತೆ ಅರೇದು, we divided it by 2 to find the mid value, that is low plus high divided by 2. So every time ಏನು ಮಾಡ್ತೀವಿ ನಾವು divide by 2 ಅನ್ನು ಮಾಡ್ಕೊಂತ ಹೋಗ್ತೀವಿ. So here first ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ divide by 2 ಮಾಡಿದ್ರೆ mid value will become 4. Next iteration if we divide by 2, that is 0 plus 4 divided by 2 ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ, that is 2. Now the mid value is 2. Again it is reduced to 2, and if I find again low plus high divided by 2, that is mid value will become, mid index will become 1. Meaning is to say, every time I am reducing the problem size by a constant factor which is 2. Every time ಏನು ಮಾಡ್ತಾ ಇದೀವಿ ನಾವು, we are dividing by 2. Understood students? So this binary search example is the variation of decrease by a constant factor. Okay students, now let us discuss the third variation, that is variable size decrease. In variable size decrease variety of decrease and conquer, the size reduction pattern varies from one iteration of an algorithm to another. So third one ಏನಾಗುತ್ತೆ ಇದರಲ್ಲಿ, one iteration ಇಂದ ಇನ್ನೊಂದು iteration ಗೆ ಪ್ರಾಬ್ಲಮ್ ಸೈಜ್ ರಿಡಕ್ಷನ್ ಏನಾಗುತ್ತೆ, ಚೇಂಜ್ ಆಗುತ್ತೆ. ಕಮ್ ಬ್ಯಾಕ್ ಟು ದ ಸೆಕೆಂಡ್ ಒನ್. ಇಲ್ಲಿ ಬೈನರಿ ಸರ್ಚ್ ಅಲ್ಲಿ ಎವ್ರಿ ಇಟರೇಷನ್ ಅಲ್ಲಿ ಏನಾಗಿದೆ, ಪ್ರಾಬ್ಲಮ್ ಈಸ್ ಡಿವೈಡೆಡ್ ಎಕ್ಸಾಕ್ಟ್ಲಿ ಹಾಫ್ at every iteration. ಓಕೆ, ಸೊ ಇಲ್ಲಿ 8 ಇದ್ದಿದ್ದು 4 ಆಗಿದೆ. 4 ಸೈಜ್ ಇರೋದನ್ನು ನಾವು ಇಟ್ ಇಸ್ 2, ಅಗೇನ್ ನಾವು ಇಟ್ ಇಸ್ 1. ಎವ್ರಿ ಇಟರೇಷನ್ ಅಲ್ಲಿ ಕಾನ್ಸ್ಟಂಟ್ ಫ್ಯಾಕ್ಟರ್ ಇದೆ size reduction, but in variable size ಅಲ್ಲಿ we cannot predict the size reduction. every iteration ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, size change ಆಗ್ತಾ ಹೋಗುತ್ತೆ. So one of the best example of this variable size decrease is the Euclid's algorithm. Euclid's algorithm for computing the greatest common divisor provides a good example of such a situation. Recall the first unit where we discussed the Euclidean's algorithm, finding the greatest common divisor of any two integers. So what was the algorithm logic? So here it is the algorithm logic. In brief, GCD of m comma n, which is GCD of n comma m mod n. This is the formula of finding the GCD of two numbers, say m and n. So let me take the example 60 and 24. I want to find the greatest common divisor of 60 and 24. So according to the formula ಏನು ಮಾಡಬೇಕು ಇಲ್ಲಿ, first position m ಅಲ್ಲಿ replace the n which is 24 comma n place ಗೆ apply the formula, that is m mod n, 60 mod 24. So what is the remainder of this one, or the result, 24. Okay, and coming to the next iteration, ಇದು ಫಸ್ಟ್ ಇಟರೇಷನ್ ರಿಸಲ್ಟ್ ಆಯ್ತು. ಆಮೇಲೆ ನೆಕ್ಸ್ಟ್ ಇಟರೇಷನ್ ಅಲ್ಲಿ ಏನ್ ಮಾಡಬೇಕು ನಾವು, ದ ವ್ಯಾಲ್ಯೂ ಆಫ್ m and n. m is 24, n is 12. So bring the 12, that is n, to the first position, comma 24 mod 12. Okay students, so ಏನಾಗುತ್ತೆ ಇಲ್ಲಿ, 24 mod 12 is, answer is 0. Now the GCD of these two numbers 12 and 0. Once the n reaches to 0, then return the value of m. Now here the value of m is 12. Hence the answer of this 60 and 24, that is GCD of 60 and 24 is 12. So ಇಲ್ಲಿ ನಮಗೆ ಏನು ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕಾಗಿದೆ ಅಂದ್ರೆ, ನೀವು ಎವ್ರಿ ಇಟರೇಷನ್ಗೆ ನೀವು ಚೆಕ್ ಮಾಡ್ರಿ. ಇಲ್ಲಿ 60 ಇದ್ದಿದ್ದು 24 ಆಗ್ತು, ಇಲ್ಲಿ 24 ಇದ್ದಿದ್ದು 12 ಆಗ್ತು. ಸೊ ಒನ್ ಇಟ್ರೇಷನ್ ಇಂದ ಇನ್ನೊಂದು ಇಟ್ರೇಷನ್ಗೆ ಪ್ರಾಬ್ಲಮ್ ಸೈಜ್ ರಿಡಕ್ಷನ್ ಚೇಂಜ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಸೊ ಇಲ್ಲಿ ಕಮಿಂಗ್ ಟು ದ ಎನ್ ಪೊಸಿಷನ್, ಇಲ್ಲಿ 12 ಇದ್ದಿದ್ದು ಇಲ್ಲಿ ಡೈರೆಕ್ಟ್ಲಿ 0 ಆಗ್ತು. ಸೊ ಇಲ್ಲಿ ಕಾನ್ಸ್ಟಂಟ್ ಆಗಿರೋದಿಲ್ಲ, ಪ್ರಾಬ್ಲಮ್ ಸೈಜ್ ಏನಾಗುತ್ತೆ, ಚೇಂಜ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಯಾವ ವೇರಿಯೇಷನ್ ಅಲ್ಲಿ? ವೇರಿಯೇಬಲ್ ಸೈಜ್ ಡಿಕ್ರೀಸ್ ಅಲ್ಲಿ. ಅಂಡರ್ಸ್ಟುಡ್ ಸ್ಟೂಡೆಂಟ್ಸ್? ಸೊ in today's session we discussed about the decrease and conquer introduction and its variations. There are three variations of the decrease and conquer technique, that is decrease by a constant, decrease by a constant factor and variable size decrease. These three variations we discussed. Okay students, thank you for watching this video.